So it can be modeled as a cone that maintains a conical shape as it decreases in size. The radius of the base of the cone is given by here's a key word, twice differentiable, where R of t is measured in centimeters and t is measured in days. The table above gives the selected values of R prime. So that means that that is a rate. It is the rate of change of the radius over the interval 0 to 12. Approximate R double prime of 8.5 using the average rate of change. So what is average rate of change going to look like then? Average rate of change implies, slope of the secant, perfect. Average rate of change implies slope, and they are telling you to find the slope from 7 to 10. So we are saying that R double prime of 8.5 is approximately, not equal to, approximately R prime of 10 minus R prime of 7 over 10 minus 7. And again, it's very important that it's R prime, not R, because you're finding R double prime. It says, show the computation that leads to your answer and indicate units of measure. So again, R double prime, it's a change or the secant. This is technically a numerical answer. You can technically stop here. Not that doing 4.4 minus 3.8 to give you 0.6 over 3 is hard, but technically you can stop there. Now, the numerator's units are centimeters per day, and then the denominator's units are days. So your units would be 0.6 centimeters per day for 3 days. Like that would be your units, or centimeters per day per day. If you didn't make days here plural, that would still be okay. But you need to have centimeters per day, centimeters per day per days, or even centimeters over day squared. So this right here would have earned you 1 point. Your units were your second point. But if you only had units and no number or work, you can't earn the units point. So even if you don't know how to do this, but you know the units, write down a garbage number. Okay? Part B. Is there a time? The minute you see, is there a time? Think theorem. It's either going to be IVT, MVT. If they say, is there a time, you are thinking of a theorem. In this case, we want to know if there is a time R prime equals -6. Well, R prime is my indicated units. This is kind of like the original function. So I know a lot of times we say, oh, if they give you a derivative, then you are doing MVT. Well, in this case, they gave you a derivative, but the derivative was our original function. So this is IVT. So is there a time from 0 to 3? So what we need to do is talk about r prime of 0 and r prime of 3. So at 0, you're at negative 6.1. At 3, you're at negative 5. So is there a time at which it would be negative 6? Well, negative 6.1 is here, negative 5 is there. So to go from negative 6 to negative 5, it would have to cross negative 6. So the answer is yes, because r prime of t is twice differentiable. It is continuous. Therefore, by IVT, r prime of 0 is less than negative 6, which is less than r prime of 3. And guarantees that r prime of t will equal negative 6 between 0 and 3. You must use IVT, and in order to use IVT, you must say that it is continuous because of twice differentiability. You must also somewhere show the box. So the boxed part is worth 1 point. This statement is worth 1 point. This would be 2 points. So you now have 4 of the 9 points. That means part C for this problem was worth many, many, many points. I think I chopped off D because of where we were learning this, and there is a D to this problem. So part C says use a Riemann sum with 4 subintervals indicated in the table to approximate. So it's a right, which means we're going to ignore the first value. I'm going to my table and I am finding the distance between each of those. And then I'm using all of the right values. So the integral from 0 to 12 of r prime of t dt would be equal to, using a right Riemann sum, 3, negative 5, plus 4, negative 4.4, plus 3, negative 3.8, plus 2, negative 3.5. This could be worth all 2 points. This right here would have been worth all of the 2 points. If you did the math, because you can't stand leaving an answer like that, the answer was negative 51. Okay.